Can I go ahead? Okay.
Yes,
So
please.
my name is Ali Akbar, and I am from Kwon University, Korea, and I will be presenting the topic remote monitoring and controller for the construction machinery using AR smart glasses. So the table of contents that I'll be following includes the research goals and strategy as to how we aligned our goals with the problem. And then we'll follow up with the literature review. And then I'll give you the development of remote control system that we have used for monitoring and controller. And then I will show you the interface for the smart glasses that we made for two devices. And lastly, I'll focus on the results and the conclusion. So for the research goals, we did some research analysis using the literature review. And after finding out some gap in the construction industry, that accidents are happening on the macro scale due to the construction machinery. So it's very hard to control the construction machinery. And as a result, accidents do happen. So one of the main reasons for the accidents is due to the lack of training of the skilled workers to operate such devices. So we need to train the workers. So the methodology that we came up with includes the following points. So we use some digital twin model to assess the monitoring of the construction machinery. And when we use smart glasses, it helps us to alleviate the communication gap between the stakeholders, the clients and the constructors. And it helps to provide safety to the workers using the safety system that we devised. And we have made the connection between the three technologies using a cyber physical system. So in conclusion, the research procedure that we followed includes firstly making a cyber physical system prototype in which we merged the digital interface with the physical object. And then the virtual model, which acts as a digital twin, we made that. And using Unity, the software, we made an AR-based graphical user interface. And we connected everything using an IMU connection that was used with Arduino. So the overall remote control AR system made some interconnection between the physical and the cyber model, and it was possible to transfer the data between the devices. So overall, our system comprises of three parts: the physical model, the server, and the virtual model. The physical model consists of the sensors and the servos, and we made the prototype. And then with the help of Arduino, we uploaded the code. So the sensor data can be received accordingly. The server acts as an operator linkage between the physical model and the virtual model. And it helps to wirelessly transfer the data between the server and the client. And for the virtual model, we used Blender to make a virtual model, and that will act as a digital twin. So for the literature review, we reviewed the past papers of 20 years, and we divided them in four key strategies, like the cyber physical system, CPS, the digital twin, the safety system, and smart glasses. However, when we reviewed the papers, we found that no existing study incorporates all of the four concepts. So a safety system using the smart glasses and employing the use of the digital twin through a cyber physical system was needed. So we made the remote control system, and for the remote control system, firstly we made the physical prototype. And the physical prototype includes the ultrasonic distance sensor, which tells us the distance from the object, and it helps in the safety and the collision detection. Secondly, we have the standard servos, which helps to move the crane arm, the continuous servo, which helps to move the hook. For the digital interfacing, we made the linkage between the server and the physical model with the AI device, and the server, the physical model with the digital twin, and lastly with the smart glasses. For the smart glasses, why we use smart glasses? The using of smart glasses is due to the fact that it helps to provide the following advantages for the administrator and the operator. For the administrator that is sitting in the office room, it helps to visualize real-time field information and also helps to remotely control the AR. And it will also act as a operator guide for the workers, and the data reliability is also improved. While for the workers operating on the construction site, this thing helps to know the location of the equipment and also helps to improve the spatial awareness. So when we have the 3D model visualization, it also helps to avoid the collision during the equipment operation. And it also helps to improve the accuracy and provides real-time two-way data transmission to and from the field to office. So the smart glasses are further divided into two types. We use two devices. One is the eyewear and one is the head-mounted device. So the interface for the head-mounted device is like this, and for the eyewear is something like this. So we need some network communication for login. We have to provide the IP address and password. And when we provide the IP address and password, we can log in, and then we can share the data between the different hardware. And there's also the controller. We can control the construction machinery for using some commands. While for the head-mounted device, the controls are a little different. We can use the hand gestures, and there are some sliders that we made for controlling. So the working process is like we first made the working assembly for the devices, for the both devices, and we have different controls for each device. Like for the HMD, we used HoloLens, and it has like hand gestures. We can use hand gestures for controlling. While for the eyewear, we use Robotics M400, and it provided buttons control. So we use the side buttons for controlling the device. And then we have the server view for controlling the model, and we can use the client view for monitoring the model. So the smart glasses, compared with the existing hardware, when we compared them, we found out that the portability is better. Unlike the traditional tab-based software and the hardware, we can actually carry them anywhere. And it is also possible to connect multiple users with the smart glasses. So in conclusion, in the future implementation will improve the connection by improving the range and latency. So we can use them anywhere, irrespective of where the construction machinery is. And the interface can be improved by making some multi-pronged and nonlinear transmission between the devices. The platforms can be improved by having more platforms like the UWP, Windows, iOS. And the algorithm can also be applied to include the multiple BIM platforms such as Rhino 3D. And this algorithm can also be further used as a data visualization and controller in various smart construction environments. So in conclusion, this paper presents an integrated framework where it can wirelessly control the construction machinery using eyewear and head-mounted devices. And basic functionality of using a cyber physical system using the smart glasses and digital twin network is done. So when we did this paper, the portable smart glasses showed the sensor distance, the rotation angle, and the movement information. So this means that monitoring can be done wirelessly. In the future, we'll focus on some other construction machinery. Right now, we did work on the tower crane, but in the future, we can move it through some other construction machinery. And we are also planning to improve the safety system, so it detects the collision and such stuff. And we are also aiming to make it cross-platform system, so that eyewear, HMD, and any AI device, they can communicate with each other.